Hello and welcome. My name is Joy Leff, and I'm a Senior Director of Development at the American Technion Society based in Chicago. Today, we're going to take a quick look back and a hopeful look forward at how the coronavirus pandemic has affected research and the larger campus community at the Technion, and has even led to some unexpected silver linings. As many of you know, we held our first webinar back on March 19, 2020, just days after Israel and the US began what we now call social distancing. Never would I have thought that 11 months later, almost to the day, we'd still be operating in this virtual space, keeping our distance from our extended families and colleagues, and protecting ourselves and each other as best we can. At the Technion, labs shifted their focus to battling COVID-19, getting special government permission to operate because the work taking place was so critical to the effort. We at the ATS, in partnership with the Technion, created an emergency fund for students and an emergency research fund to help in these critical areas. At one point, more than 50 labs at the Technion were conducting COVID-19 related research. As ATS President Steve Berger wrote to ATS supporters back in March, we look to the Technion for inspiration. The Technion is responding to this global crisis by reviewing ways in which they can make immediate impact. They also remind us that crisis is not new to Israel, and the Technion continues to prepare the next generation of leaders who will solve for and prevent the next global crisis. Steve was right then, and it's still true today. I'm delighted to be joined today by Professor Alon Wolf, who, as a new member of the senior administration at the Technion, was on the front lines of decisions being made minute by minute in the early days of the outbreak. Alon is not only the Technion's Vice President for External Relations and Resource Development, he's also Director of the Biorobotics and Biomechanics Lab, which was and is conducting some incredible research related to the pandemic. Alon will be joined by Professor Yair Ein-Eli, who serves as the Dean of the Material Science and Engineering Faculty, Assistant Professor Yoni Savir of the Technion's Rappaport Faculty of Medicine, and Assistant Professor Naama Geva-Zatorsky, also from the Faculty of Medicine and a member of the Rappaport Technion Integrated Cancer Center. Technion President Uri Savan has made the interdisciplinary nature of the Technion a cornerstone of his administration and vision for the university. And our guests today are prime examples of that. The combination of science, engineering, and a medical school quickly put Technion at the forefront of this fight, facilitating solutions for the benefit of humanity. We are proud to welcome our guests today, who highlight the spirit of innovation and cooperation the Technion embodies. Just as a reminder, to use the Q&A function on the webinar screen to submit your questions for our guests. And we'll get to as many questions as we can at the end of the program when my colleague Vicky Booter joins us. It's now my pleasure to welcome Professor Alon Wolf to the program. Alon?
Hi, Joy. Thank you. Thank you for your nice introduction, and thank you to our audience. It was, and it is a challenging year for the Technion and for us as a new administration. When we stepped into office in October 19, I don't think we've imagined what the year is going to be and what challenges this COVID-19 is going to bring to us. So right after we assumed the position, kind of 3 months later, of course, in March of 2020, the campus was shut down one day. And one of the first things we had to deal with as new administration is how to continue educating our students and providing all the services to our students, whether it's labs or teaching. And in almost no time, like many other places, we had to convert to online teaching, which was a great challenge to professors and to the system. And, as we do things well and very efficient, we did it. And we were able to switch on all classes to online teaching in less than a week. Also the exam system. And actually, we're still teaching online until today, although we were hoping at some points to switch into what we call hybrid teaching, which is if we're able to have some of the students physically in classes and the rest actually using online system to follow the classes. Unfortunately, the latest development doesn't allow us to do that, and we're still in completely online teaching and exams. But I think we learned a lot. I think if we hope before the crisis to switch some of our courses to an online system, getting our students ready to the future of what we call continuous education or lifelong learning, where we expect our students to continuously have to re-educate themselves and learn things as science progresses very fast. Now we've experienced how to do it and do it efficiently, and we're hoping that after this crisis or the virus is defeated, we'll still continue to have some of our courses online to the benefit of our students. Now, one thing that happened right after we switched, we were challenged with the first lockdown, is I got a phone call from the director of the Rambam Medical Center that is affiliated with our medical school, and we held together some kind of a Zoom call where we started discussing some of the challenges that the hospital is confronting and whether our researchers or technology that we have on campus can assist the hospital. This phone conversation resulted in with several exciting projects that some of them are actually being implemented and used now in hospitals in Israel, in some of them even worldwide. And I'll show you some of the examples. And of course, the following speakers will also tell you about their experience and what they've developed. The thing is that we were able to do that and very fast is because our researchers were able to take a lifelong research that they've been doing in their labs and convert it very quickly, as mentioned before, to challenges that the virus is bringing on us. So they take their knowledge and very fast were able to adopt technologies to deal with the virus. As we say, never let a good crisis go to waste. I think we've learned a lot how to be flexible and how to deal with crises, and pretty successful. Now, I'd like to share with you some slides to show you how the campus looks like during the Corona crisis. So let's see if I can share it. I hope that you can see my screen. So for those of you who know Haifa, Haifa is well known for its tourist attractions, which are unfortunately closed right now. So if you'd still like to get a falafel, it's going to be pretty difficult because everything is closed. This is our campus, the Haifa campus, the big campus in Neve Sha'anan. And this picture was taken right after the first lockdown. And this is the roof of our visitor center, where I tried to have a meeting of my my staff, and we had to keep the 2-meter distance in an open environment. This was around April of last year, so you can see the people sitting on the roof. And this is a picture I took actually today, and you can see the flowers on campus. But one thing, please notice that there are almost no one on campus. The campus is pretty empty. Students are at home, and although everything is packed with flowers, no one actually enjoyed it. So these are pictures from the campus as it's been, right now. As I said, the researchers actually, many of them, actually more than 60 labs, joined forces to try and fight this virus. And by the way, this is our gate, the main gate to the campus, and you can see the signs that we put there on the electronic board that keep calm, stay at home, we are working on it. Well, as we said, if you walk on campus, it's pretty empty, but inside the labs, people are working 24/7 trying to come up with solution and teaming up with medical centers around in Israel and our medical school to try and come up with a solution. One of the most advanced, I think, solution that came out of this effort is the Maya sticker, which was developed in Eyal Zussman's lab, Professor Zussman in mechanical engineering. Taking his knowledge on nanofibers, he developed this sticker that you attach to a regular mask, and this mask is being now converted to almost 100% safe, and it captures the virus and actually destroy it. So you just put it on any conventional sticker. This sticker is now any conventional mask. This sticker is now approved for use in Israel, and I know it's also used worldwide, and technology was licensed to a company now produces these stickers. Another development that came out of this crisis is by Ezri Tarazi. One of the main challenges is for medical teams to protect themselves from aerosols, and he developed this vest and this visor that protects
So, good evening from Haifa. I'm situated at home now. It is after 9 o'clock in the evening, and a little bit of my story. I'm far away from being a medicine guy or even close to understanding medicine. However, I serve as the Dean of the Department of Material Science and Engineering. I'm 55 years old, married, and father of 3 sons, aged 31, 28, and 26. I live in a walking distance from the Technion, and I usually was walking to Technion and home by foot. As an energy guy, I strive to save energy and use my transportation, which are my legs. So I have graduated from Bar-Ilan University, it was a while ago, and did my postdoc in a private research company in the Boston area. I returned back to the industry as a vice president of R&D in a battery company called Electric Fuel, situated in Bet Shemesh, nearby Jerusalem. And Electric Fuel produces, at that time, fuel cells and batteries. After 3 years, I joined the Technion as the research at that time in the company was applied, and I was looking for much more basic research. And actually, I suffered from the obligations of being a vice president of research, including handling manpower. So 20 years ago, I was lucky to meet one of the biggest electrochemists alive still, Professor Eliezer Giladi, and he told me that the Technion Materials Engineering Department, they're looking for a corrosion scientist. My reply was that I'm truly not well fitted to the description of a corrosion guy, but nevertheless, I applied and I was hired. So I came to the Technion with the hat of a corrosion PI, but nevertheless, my passion was energy storage. So I dealt with batteries and corrosion and merged the research together to combine the two in order to produce new energy devices or energy storage devices. So we explored corrosion processes in fuel cells and batteries, and also combined electroplating method to enhance the performance of the battery. And a while ago, 10 years ago, we invented the silicon air batteries concept, which was new. And we established 2 startup companies on aluminum and silicon air. And the coronavirus caught me actually in the middle of my endeavor with energy storage devices. And at that time, a year ago, we were dealing with flexible batteries. And flexible batteries, we used carbon felts, carbon fibers, in order to promote the no need for metals, specifically aluminum, copper, and we use copper carbon fibers. And in these carbon fibers, we're stuck, and we did research, and we had at that time 50 types of carbon fibers in the lab. So by mid-March, I was the dean, and everybody were evacuated from the campus, and I maintained coming in each day in order to look that everything is on place, all the tools are working, because we have a microscope, heavy microscope, and which is expensive and needed some guidance. So in one of the days, I pick up the phone in the office. I was the secretary as well, and the UPS guy is calling and says, would you come down and pick up the package for Professor Rapkin? So I'm going down, and I see the UPS guy with a mask on his face, and I'm asking him, why is the mask so dirty? And he replies that this is the only mask that he could get, and he's wearing it for the whole week. And I looked straight. I looked at him puzzled, and I said to him, you mean you cannot buy mask? And he said, no, I cannot. So I went to the web, and I understand that in the US there was a gap, and there was a shortage of facial masks, even from medical crews. So I called Shulamit Levenberg, Professor Levenberg, who was the dean at the biomedical engineering department, and I asked her, what is the temperature that the virus is being killed or eliminated? She pointed on a research, the first research that showed that it is 60 degrees. So I came home, I took some masks from the warehouse at the Technion, and operated the oven at 70 degrees and throw it into the oven, my oven at the kitchen. And after 3 hours, I pulled it out, and I saw that everything is fine. So now the question is, well, the mask is stable. Now, how do we get the oven inside the mask? So the idea was simple. Let's take the carbon that I have in the lab. Let's put it into the N95 facial masks, and we'll connect it to electrical plug. So the easiest plug is this plug, right? This is the iPhone or Samsung or cell phone plug, mobile telephone. So we had to adjust the carbon fibers and the heat generated to the current that this charger would allow us. So within 2 weeks, we had 2 masks that could heat in 15 minutes to the right temperature of 65 degrees that eliminate the virus. So this was a big success. We wrote a patent within 3 weeks, and we declared that we can kill the virus, but we didn't have any proof. So the next step, of course, was to join forces with the biologic department. And there I met Professor Beja, Oded Beja, and Professor Debbie Lindell. And they are collaborating with us till now in order to understand how the virus is being eliminated. So we are not working with real coronavirus, of course, but we are working with a mimicking of the coronavirus, which is friendly, and we are successful in eliminating the virus. Now, at that time, there was a shortage in facial masks. Today, 1 year after, there is no shortage. So there are plenty of masks, but the problem is that they are disposable. We are throwing them away. We are actually contaminating our planet. So the solution might be eventually to use the same mask over and over again by heating it and eliminating the virus. So other projects in our lab are aimed at, of course, batteries and fuel cells, but this kind of spin-off project was because there was a need. We had the materials, and we just had everything in our hand in order to do what we did. We have other projects in our department, for example, self-cleaning surfaces, drug delivery polymers, protein functionalizations. And I became an expert in evaluating proposals, especially for the ISF on Corona, dealing with masks. So I didn't intend to be a specialist on masks, for example, or how to eliminate viruses from masks, but apparently they need somebody with battery to do that. So this was a short story of how a guy that has no knowledge in medicine, just a battery guy, could plug and make it rechargeable, or just plug it in and eliminate the virus. And this is a short story, but it's a lesson. It's a lesson that, first of all, we can overcome some problem, challenges quite quickly. Second, we can work together with other departments. So people that I never knew of them, suddenly they become colleagues and partners for research. And last, we might have a solution which is pinpoint solution, and eventually everything will be done in a year or two, hopefully. So whatever we're doing now will allow us maybe to shift it to other applications, and I'm certain of that. So thank you very much. So I'm handing it to Yoni. This is Yoni, who I present now, and welcome.
Pull up my presentation. So I'm very happy to be here and share with you our Corona story and our research in general, and how this research led to all this Corona science that we do. About myself, so my name is Yoni Savir. I'm an assistant professor at the Faculty of Medicine at the Department of Physiology and System Studies here at the Technion in electrical engineering and physics, and went on to the Weizmann Institute to do a PhD in theoretical physics of complex systems. And one of the most complex systems that we can think about is a biological system. And during these years, I started to engage more and more in biological systems, in the design principles, the revolution. And that led me to do my postdoc at Harvard Medical School, where I studied evolution of cells. And in 2015, I went back to the Technion, to the Faculty of Medicine, and in my lab during the last few years, we are focusing in two main things that at the first glance are not connected to Corona directly. The first thing that we are really interested about is understanding failure in physiological and cellular function, in particular as the system age. We love to think about these systems with the glasses of an engineer, trying to understand function. And here you can see a few examples of the system that we work about, how the maternal age of the mother affects the development of the embryo, and how stem cells develop dynamics deep learning. As you probably all know, we are in the big data era. And in order to analyze these huge amounts of data, to get new insight, we have to use more and more sophisticated tools, and machine learning. I hope it's better now. And we harness machine learning not only for research questions,
Okay, so we're going to move on to Naama.
okay, I'm back, or
You know-
okay.
Yoni, are you back?
Yeah, I think I'm back. Should I
Okay,
continue?
Let's continue, sure.
Okay, so let me reshare the screen again. So I was talking about thermal imaging, and which you probably all more familiar with during this last few months. It's been very, very popular in screening workplaces or airports and so on. And thermal imaging is basically a method where a radiation that it is proportional to the temperature of the object is captured by a sensor. So here, for example, you can see one of my bright student, Tal Ben Yaakov. He's an MD PhD students, one of the students that are doing both medical studies and research. And you can see Tal in his three forms as a nice young man and in his thermal representation. And prior to the corona, we harnessed AI to use very, very cheap a thermal sensor to capture temperature very accurately, and more important, breathing patterns. So measuring breathing patterns from a distance is a very, very hard task. Usually it requires either a contact, a sensor that physically touches the person, or it requires a very, very, very sophisticated techniques like laser or radars. And we were actually developing this type of devices for the military and for homeland security applications. And that happened. So I want to give credit to my daughter. I always wanted to do that, who drew this nice picture of the coronavirus. And that, of course, changed all of our lives. And it happened to be that the solution that we developed to measure this temperature and breathing patterns are exactly what is needed in order to screen for the coronavirus and viral infections in general. And the challenge here is clear. We need to monitor the physiological parameters of a huge population, and we have to do it quickly with cheap sensors. And we have to minimize the risk of the personnel who actually make this measurement. And the most important parameters that we need to measure are the body temperature distribution and the respiratory dynamics. A week ago, the World Health Organization actually published that after all the many papers that has been published during the last few months, the most important parameters are actually the ones that we thought was relevant at the beginning, which are body temperature and the breathing patterns. And estimating both of them in a clinical resolution is not trivial. So many of you are probably familiar with these IR thermometers that are used again in the workplace or in entry to all kinds of places. And the problem with these thermometers that although they can work from a distance, they don't have a clinical accuracy, which means that we cannot use them in the clinical settings. And the reason that it's very hard to estimate in a clinical resolution the body temperature is twofold. First, we have to estimate the temperature of the skin itself, which is very hard to do from a distance of a few meters. So from 20 centimeters, you can do it with cheap sensors. But if you are talking about few meters, it's getting harder. And the second challenge is that even if you measure the skin temperature, it's very hard and non-trivial to infer the core temperature itself from the skin temperature. Measuring breathing patterns is actually harder. To do it without any physical contact with the person involves very expensive solutions, like all kinds of radars that actually monitor the motion of the lungs, and from that infer the breathing rate. So our technology that used AI and machine learning to utilize very cheap sensors to measure exactly these two properties was very suitable to meet the challenge. And the nice thing about, I think, about the Technion and in Israel in general is that the ability to carry out collaborations and very complicated projects in a very short period is wonderful. So only a few days after the first quarantine that happened here in Israel a few months ago, we got a call from our collaborators at the IDF and in the Israeli aerospace industry, and we all got together. What you see here in the picture is a roof of a building in the center of Israel, where we spent, I think, 7 days in a row, sitting on this plastic table, and we were just modifying our technology and technology of our partners to utilize it for clinical needs. And in a very short period of time, we were able to construct a system that is termed Tamar, which is the Hebrew name for the palm tree, one of the 7 species of Israel. And this system was validated in the Bellinson Hospital at the center of Israel, and was almost immediately located at the emergency room and in the Corona department, where we measured a lot of data and constructed a system that has a clinical resolution of measuring both temperature and breathing rates and other properties of the breathing patterns in a clinical resolution. And this system is now on the market, and it's being tested and sold to health providers and homeland security agencies worldwide. So the next steps is, of course, to try and not only measure the physiological parameter, but also to infer some clinical decision from them, to develop a decision support system that will allow us not only to measure, but also to screen immediately. You can imagine just measuring the breathing pattern and the temperature distribution, and immediately have some probability about the risk of infection of the subject. And this is important not only to COVID, because now we have vaccination and hopefully COVID impact per se will go down in the next year or so. But I think that one of the lessons is that we have to be more prepared to the next viral infection. So we had SARS in 2009, and then we had MERS, and now we have COVID. So we have to be prepared also for the next one. And another byproduct, which is very important of the COVID-19, is that it facilitated two trends that were already emerging, but really got a boost from it. And this is the field of digital medicine and the field of telemedicine. So in the last 10 years, we started to incorporate machine learning into the clinics. Big data is emerging, and remote sensing technologies are here. And I think what I told you is a good example of a technology that was there, but COVID-19 actually facilitated its application and integration into the clinics. And this removal of organizational barriers actually gave us an opportunity to really go into this era of telemedicine and digital medicine faster than we imagined before. So I want to thank you, and I want to thank the guys in my lab who did this wonderful work with a lot of effort. And I would like now to welcome my colleague in the faculty, Naama.
Thank you very much. I really enjoyed, and thanks for handing over. And many of the points will be actually matched. So it was a great introduction and starting point for many of the things we'll talk about. So nice to meet you. I'm Naama Geva-Zatorsky. I'm an assistant professor at the Faculty of Medicine of the Technion, the Rappaport Faculty of Medicine. I joined 3.5 years ago after a postdoc at Harvard Medical School, side by side with Yoni, and a PhD at the Weizmann Institute, also side by side with Yoni. We kind of moved together. So during my PhD, I studied actually dynamics of proteins in cancer cells, also a systems biology way of thinking. And I always wanted to study microbes, these unicellular organisms that can perform so many and so complicated functions and can contribute to our physiology. I thought this is fascinating. So I joined Dennis Kasper's lab at Harvard Medical School to learn about these microbes that live in and on us, and to understand how can we harness them for our therapeutics. So they're important for our lives, essential for us. They help in our food digestion, they educate our immune system, they provide us with vitamins and invisible defense layer. And in the past 2 decades, they have been shown to be associated with many diseases. So when I joined the Technion, we actually built facility that allows us to study this these microbes. It's germ-free mice. facility, mice that don't have any microbes in and on them, and we can introduce whichever microbes we're interested in to study their communication with our physiology and mainly with our immune system. Just briefly, during my postdoc and in the lab, we study how can we rebalance our immune system with these symbiotic microbes, with these microbes that live in and on us, and especially in our intestines. We learned that many of these microbes can contribute to many arms of our immune system to develop a fully mature and healthy immune system. We understand that they can perform different functions, and now we're actually studying their functional roles in many types of conditions. So at a different talk, I can talk more about that. I'll just mention that in lab, we also love to develop technologies. One of these technologies, this technology that I'm showing here was developed during my postdoc at Harvard Medical School, which was to enable visualization of these microbes. These microbes live in an anaerobic environment in the intestines without any oxygen. So we're limited with tools to visualize them. And this is one technology, the first technology that allowed us to visualize them live in live mice. So these are real microbes swimming around a live intestine of a live mouse. In lab, we are continuing to develop this technology and many more. And actually during the, this is just to show that this enables also to study how they communicate with our immune system. So we love developing also tools in parallel to studying the mechanisms of this communication between microbes and host. And during the first pandemic, we were locked and really just couldn't bear the fact that there is a virus, a biological virus running around, making the world go crazy. And we as biologists are sitting at home. So we brainstormed nonstop within my lab. This is about half of my lab, Nadav, Tal, Haitham, and Rawi. But many of the lab members helped here. They're all listed here. And we realized that there is, we can probably work on a method that can allow us to detect the virus in a very simple and rapid manner. So I'm saying probably because that's what we thought back then, but we succeeded to do this. And right at the beginning, back then we had to get permission from the Technion to work on COVID-19. And I remember the email by Kobi Rubinstein telling me that this sounds crazy, but crazy ideas sometimes succeed, so go for it. And he and the Technion allowed us to open our lab. The Rambam Hospital also was amazing, really quickly just understood the potential and helped us approach human samples and work on viral samples in their corona lab. And that was mainly Professor Michal Powell and Moran Schwartzworth-Cohen, but also many others. So the idea was to develop a diagnostic test that can be rapid, simple, easy to use even at home, to reduce pressure in hospitals, to enable surveillance of the community, and to provide a more epidemiological, safer environment. And the idea is actually it's a molecular test. It's a molecular diagnostic test. So just like the molecular diagnostic test that is done at hospitals with the swabs, we amplify the nucleic acid of the virus. However, it's with an enzyme that allows this amplification in one temperature. So this reaction is performed in a pink media, in a pink liquid. The enzyme is in this liquid. This is how it looks. The enzyme can amplify the nucleic acid of the virus if it's there directly from human samples. We first did it on swab samples, but quickly moved to saliva, and now we're concentrated only on saliva samples. And if the viral nucleic acid is present, protons are released due to this amplification process, and the protons reduce the pH, and the pink color turns yellow. And this is how it looks in reality. So this test can be performed one by one, or even in 96 well plates, just as the one shown here. We published this work in scientific journals, and quite quickly, with the help of the Technion, founded a startup company that allows us to implement this to the society. As I mentioned, it was a really close collaboration with the Rambam Hospital throughout. So this test is now saliva-based. It has high sensitivity at the infectious range. So I'll just elaborate a little bit on this. At the hospitals, there is a machine that can detect the viral nucleic acid as well, and that defines how much of the virus do you have. We can detect the virus while you're infectious. So sometimes the test at the hospital can tell you you're positive even before you're infectious, or a little bit after, but it's totally fine. It's great. It keeps us safe. Our test is very sensitive only when we are infectious. It's a disruptive modular test and can be a scalable, very rapidly scalable. It's quite fast, not minutes, more in the order of an hour, like 40 minutes. It can be done on the spot, no need for professional equipment or experience. It is now also cloud-based, and it's a platform. So like Yoni said, also here, it's now routed towards the coronavirus, but it can be easily adjusted to other viruses or to multiplex the influenza and the coronavirus, or even microbes if we connect it to the other studies we're doing in lab. Right now, there is a use case at the Technion, so it's a Helsinki-approved experiment, actually. And the students, we decided to do this with a lot of help of the Technion people and management. And there is a station at the upper campus where students and any person that is inside the Technion, workers or guests, can come and test themselves. It's very simple. They scan with their phones the QR code. They just need to spit into a tube, and in a couple of hours, they receive the results on their phone. So this is our president scanning this QR code before he performed his test. There is a consent form. And then this is how it looks on your phone. Sorry for the Hebrew, but green is negative. So to mention again, just that this company was founded by us and Dr. Oren First, who was a faculty at business school in Columbia and Yale. And we have also a team with really cutting edge professors in Israel and around the world. And we are closely working with Moran Berkovich on a home-based device now. Moran is in the engineering faculty in the main campus, so in mechanical engineering, and we're working together. It's really fun. That's also one of the great advantages of the Technion, this cross-disciplinary technology oriented. It's I'm really enjoying it. So we're working on with Moran on a device that will allow really like we call it lick and click, and everything will be performed in one device. And also Professor Ezri Tarazi that was mentioned this evening already, who was helping us to design and create this test in a functional and very easy to use way. It's also extremely exciting to work with him. So I'll mention that this work was really fun, but extremely also I don't know if but, it was really fun and extremely hectic in the good way. We just came to lab, worked like crazy, slept on the sofa, ate together as much as we could, and a few of us, the ones in the picture, came physically to lab, and the other part of the lab were at home, and we really like worked around the clock, like Yanni also mentioned, and with his team, perform the experiments, analyze them. Like people wake up at 2 a.m. What can I do? What's next? And we really like felt that this should go out to the world as soon as possible. And the Technion and everyone really helped us with that. It was quite an experience, and still is. We're also working now with the Ministry of Defense to also implement it to the public. I'll just mention also that we have developed another technology, and another startup was founded called Biotox to analyze, diagnose, and treat diseases based on the microbiome. I won't talk much about it. I'll just mention that my co-founders are Dean Light and Shai Hillel, and it's a really exciting endeavor as well. Happy to talk about it offline. And I would like to thank you, and I'll move to Alon, and happy to answer questions later on. Thank you.
Thank you, Naama. I'll try to keep my camera off so I can, and sorry for being disconnected before. I think what you've seen here is an excellent example of what I said before, how researchers responded fast and took years of experience and used the knowledge to challenge COVID. And, you know, all the examples you saw here are a result of, you know, years of work in labs that were, you know, with very good intuition were converted to challenge the virus. Now, I want to finish what I started sharing with you before, and show you this the slide. And we mentioned Ezri Tarazi, and Ezri was among the first, I think, researchers that responded to the call by Rambam and developed this helmet that produced like a screen of air to protect the doctors from aerosols to get into their respiratory system. This system again is being implemented around the country in many medical centers. Now, you may have read or heard in the news how dogs are being trained in Europe and around the world, and also in Israel, to sniff and identify people that carry the virus, carry corona. It's been known that, you know, dogs can detect, of course, drugs and other things that are trained to smell, or cancer, for as an example. So this idea, this inspiration, bio-inspiration, actually inspired Professor Hussam Hayek, our very famous Hussam, who developed the artificial nose, his artificial nose to detect cancer. Now, when the COVID broke, Hussam very quickly was able to convert his device to smell and detect COVID. So you just blow air into the device, and if you carry the virus, then the system or his sensor would alert and say that you're infected. Actually, he had the privilege to present his work to His Majesty Prince Charles when he visited Israel in between lockdowns. Now, you all heard Naama on the left-hand side here of my slide, but I want to mention another project that is ongoing here on campus. You know, a few months ago, when we opened the campus right after the summer break, we were, as administration, very concerned of the students that are going to return to the dorms. We have about 4,000 students in the dorms on the campus. We have more beds, but not everyone came back to campus. And one of our main challenges was try and detect as fast as we can whether there is an outbreak of corona in the dorms. So Eran Friedler, Professor Friedler from Civil Engineering, helped us by implementing his system in the sewage system, actually, of the dorms and the university. where he puts sensors into the sewage system and detects whether there is COVID viruses in the sewage system. So it turns out that if you are sick, you actually in the toilet, the virus go into the sewage system, and the system is so accurate that it actually detects a single person in a building. And we were very successful to detect very fast students that are sick and isolate them, or ask them to take, of course, Naama's test before we isolate them, just to confirm that they, that they're indeed sick. One more, I think, project worth mentioning is the one which is related to an outreach activity that the Technion has been doing for the last 17 years. Technion has been responsible for one of Israel's largest STEM education program in the country. It's called FIRST Robotics. And one of the main challenges I was introduced to when I spoke with the director of Rambam the medical center right at the first lockdown, is to try to protect the healthcare givers by using robotic system to treat, or actually to serve, the patients within the corona department. So since I know the first robotic competition quite well, I ran the program for 17 years as representing the Technion, because the Technion is running the program. I approached one of the local schools here in Haifa, the Reali school, and asked the team to take the robots that they used for the competition, which were canceled, and convert them into robots that could serve inside the corona departments. Now, the school students immediately volunteered, and they spent 24/7, almost for a week, developing this. This is in the school, a robotic platform that can actually travel inside the department and deliver food and drinks, and maybe take not blood, but pulses of patients, those that can actually collaborate. On the right-hand side, you could see actually the director of the Corona department and Rambam, and the robot being implemented in the hospitals. Now, the benefit of this project, of course, is the help and assistance of the robot to the medical team. But I think the educational aspect of the project are profound. The fact that school students, 16, 17, and 18-year-old students, realize that using STEM technology and engineering, they can actually help society, help people. Now, they are our future. They are the future students of the Technion, the future engineers, the one who are going to make a difference for us. With that, I want to thank you, and I want now to switch into the Q&A part, and we'll be happy to answer your questions.
Video. Thank you all for such fascinating insights. It's incredible and inspirational to hear about where you started and where you ended up in such a short time. And it gives me much hope for a brighter day when I hear from remarkable people like you. I'm happy to now turn the mic over to my fabulous colleague, Vicki Buder, Senior Director of Development based in the San Francisco Bay Area, who will moderate the questions from our viewers.
Thank you, Joy, and thank you to our panelists. I have to say, I am always in awe when I listen to the remarkable research that's happening at the Technion, and I am proud to be a part of this wonderful group. The first question that we had, I would address to Alon, it's about the Maya mask. People wanted to know if it was approved yet in the US, and if it was available, and will it be available worldwide?
Well, it is used worldwide. I don't think it was approved yet in the United States, but I know it's being used in Europe, in the Far East, and of course in Israel. In the United States, I don't think so. Last time I checked, it was not approved.
Thank you, Alon. Naama, Regarding the RT-PCR test using saliva, is it approved in the US? One of our guests would like to know, because they thought it would be a remarkable thing for airlines, cruise ships, schools, an ideal place to use it. So,
thanks for the question. There are options to implement it in the US. It's our specific test right now is not approved, but the similar concept can, I mean, we can talk offline and I can explain in more details, but it's definitely a valid option. And I agree, yeah, airlines were approaching us, it's true.
Thanks. I can connect you offline, and also there was a similar question from this guest about investing in the company, so I will connect you as well.
Thank you.
And then a question more general: how does the speed of vaccinating the entire Israeli population impact the herd immunity of Israelis? And as we don't know the long-term efficacy of the mRNA or other vaccines administered, what are the potential impacts of that? And maybe anyone could take that question.
Well, I'll take I just heard in the evening news today that actually we start to see the impact of the vaccine. The numbers are dropping now. Numbers were very high in Israel, and the reports today are more optimistic. You can see the drop, especially in the group age of the population that was vaccinated. I think that now with the new mutations, the one from the UK and South Africa, the herd immune was assumed to be around 60%, I think, as most viruses. But now I think the estimation is you need to reach really something like 80 to 90%, because the vaccines are not as efficient as they were supposed to be to the new mutation that were discovered. But there is a clear evidence that the vaccines are making a difference. There is a drop in the number of infected people, one hospitalized in intensive cares, and it was just broadcast 2 hours ago in the evening news. So this is really, this is good news,
Thank you, Alon. Are there any vaccines under development in Israel currently?
Well, again, there was one that supposed to be developed early last year. I think there were several discussions about the vaccine, but I don't think that now that we have the Pfizer vaccine here in Israel, I don't hear more. I don't know, Naama or Yon, if you heard more about this vaccine, but I think that most of the population here in Israel received the Pfizer one. By the way, that you probably heard that the CEO and president and chairman of Pfizer was awarded honorary doctorate of the Technion, and is about to receive it in hopefully this coming November, if we can all meet face to face to appreciate his vision and his no doubt this vaccine is made a big difference. So I'm not aware of the Israeli vaccine being implemented.
Thank you. Maybe
I just want to say something about that. So the Israeli vaccine is not implemented, but is developed and tested on a small population. It has a different method than the Pfizer method, but from the small set that it's already been tested on, it has very good results. But not in the next month as a solution.
Thank you, Yoni. Do you foresee a use for Tamar in a hospital to quickly measure temperature and respiratory rate along with pulse and blood pressure regarding vital signs? Alon?
So it was about Tamar. So should I answer that?
Yes, yeah,
Okay.
Yoni, probably you.
So yes, so actually it's already in the hospital. So it is being used for the last 4 months in the hospital itself, exactly for that purpose. So yes, absolutely.
Thank you. This question from Mark Gaines, maybe for Naama, is the saliva test also successful with the mutations of COVID?
Thanks. So the mutations that we know of right now do not affect the saliva test. I can say that in the future, we hope no, and there won't be other mutations, of course, but if there will be mutations that will affect it, it's very easy to adjust the test accordingly.
Thank you. I think we have time for about one more question, and then if people have questions that we were not able to get to, please feel free to send me an email and we can try to address those for you. The last question is about the new protein therapy discovered to help 30 Israeli patients with 100% successes. Of course, I think that was a big story here this week, so I'm wondering if any of you could speak to that. What you think about that? Yoni? Yoni, how about you? Any comments on the?
I think it's very promising, obviously, but we have to still have to account for several factors, but it's a very promising, no doubt about that.
It's the specific protein that's supposedly the first medicine to alleviate COVID.
Exactly. So within I want to be careful in what I say. So within the cohort in which it was tested, huge success. It's remarkable, but we have to move slowly towards larger cohorts and more diverse one, but it's very promising, yeah.
Great, thank you.
As a matter of fact, if I may step in, there are 2 medicines being developed in Israel. One is in Hadassah and one is in Ichilov hospitals. The one that make the waves in the US and worldwide is the one that was developed in Ichilov. But again, this is the silver line that we see there. A guy was working for 20 years on some applications, and suddenly the puzzle, he just made it a fresh puzzle in his eyes. So he was at the right moment, and he had worked on it for 20 years. So it doesn't mean that people who work on it for 1 year will be able to do that. The same with the other company working with Hadassah. They report huge success, but again, there has to be protocols for such medical, and they are following it. It will take time, of course, but these are 2 shining and brightening stars in Israel, yes.
Thank you. I think, well, we do have time for one more question. It's regarding the eNose technology. Is it in early detection? Is it early detection? I'm sorry. Alon?
As far as I know, it is, and actually Professor Hayek already also spin off a company out of the Technion to further develop this technology. Yeah.
Thank you. Thank you very much for your answers and your time today. Joy?
Thank you, Vicki. And thank you all for the fascinating year in review conversation. I wish you all continued success in your professional endeavors and good health for you and your families. We look forward to a time when we can have you here with us in person. To all of our attendees, these times remind us of what matters most: families, loved ones, and community. Thank you for being part of our incredible ATS and Technion community and all that you do to support it. And thank you for joining us today. Be well.
Thank you.
Bye-bye.
Thank you.